Hi, my name is Brian Wasserman. I am the Senior Director of Engineering at Partech. I am the head of the engineering organization for the Brink point of sale system. Our system is a restaurant point of sale system. It's cloud-based. Our mission is really to go out and connect our customers with the meals and moments that they love. And we are one of the largest companies operating in the space and aiming to get a whole lot larger this year. Which is why the subject of load testing is near and dear to my heart. All right, so what I'm going to cover in the talk today is really just talk about, kind of introduce load testing, talk about why it's needed, why I'm semi-qualified to talk about this. I've got a lot of experience in this area. And as I go through this, I'm going to talk about some of the different systems that I've load tested over the years or been involved in load testing, and just talk about some of the lessons learned along the way. Okay, so let's start with the probably the most important question, right? Why is load and performance testing needed? What are the benefits of it? Honestly, it comes out to being a key factor to a successful user experience, right? We all want our systems to run. We all want them to not tip over. We all want them to have good response times and scale properly based on our expectations. And so what we're really looking to do is ensure a successful user experience and understand what the limits of our system today are so that we know when we need to address them. Some of the specifics that we look at really have to do with whether we can handle a certain number of users, looking at response times for requests or for web pages. How does the system perform under peak load, and does it revert back to a normal mode after peak is done? One of the customers or one of the companies I worked at, we used to have a constant load, and then we would open up certain race registrations and we would have a big peak that we'd have to handle with the system. And we'd have to know that the system could both handle the peak and go back to its normal state afterwards. Sometimes scalability is measured in terms of users. In our case at Brink, we look at the number of store locations we have, the number of registers that need to connect to our system is a big driver of load. We want to make sure that, under periods of sustained high load, right, systems continue to run, that memory usage, response times, CPU usage all remain fairly constant. And then a big part of our system really is understanding, once you have a good benchmark of your system performance, you want to make sure that it continues to stay the same or improve performance with each subsequent release or each subsequent iteration of your software. So that's a big part of load testing. And then the last one really has to do with understanding how systems should be sized and how they should scale. Our current system is based on AWS cloud technology, but we want to understand how we size our system so that we are not paying for more AWS resources than we really need. So all load testing at the end of the day really is understanding, do we understand how our system behaves under various circumstances? And do we understand, going forward, based on growth targets, when do we need to start upgrading our system? So my personal experience with load testing, I've been involved with or personally done hands-on load testing of 4 different types of systems. So, and I'm going to walk through each of these and kind of talk through the lessons learned along the way. I used to work for Active Network, and one of the systems that we had there was registration websites. So I've got extensive experience hands-on load testing one of them and being involved in our SaaS-based offering that came out a little bit later. Our current system at Partech, our Brink POS system right now is a monolithic vertical stack application. We're in the process of re-architecting that into the AWS serverless architecture. And so we also have load testing efforts underway on both of these. All right, so what I'd like to do really is walk through some of the examples that I've been part of. I'll describe this first one. When I worked for Active Network and I first started working there, we had a registration system. We did high-end endurance events. So if you run 5Ks, 10Ks, triathlons, marathons, a lot of that registration went through our system. And the original system that we had was a mess of cold fusion, spaghetti code, along with some Java pieces of technology. And we had 3 events throughout the year that were so big in terms of the heavy volume of traffic that they knew it would crash the entire site. And so while they debated how they were going to invest in the site and improve it, what they did was they actually wrote these one-off websites to handle these specific registration events. So that means you're creating a one-off website. You have exactly one chance to get it right. The way these sites worked is we might work on them for about 6 weeks ahead of time, put a lot of load testing into them, and then we turned them on, and usually within a number of hours, the entire event sold out. And that meant that if the event failed, it was super public and super bad press for the company. It was a very simplified website. It literally was one page to put in your information, process an order, save it. Second page was a confirmation, and then everything else was an asynchronous process that ran in the background. This event, prior to me joining and taking over this event had failed about probably half the time. And so the load testing really in this case was much more about recording that registration flow, and then using a load generation tool to replay that time for 10 users, and then from there out, scale it out to be 3 times the expected peak load. And that was our goal. So again, this was extended. What we did for the first set of tests were a simplified test. It was a website operating against only one server in the background. This was all Java code. So it was one Java service running in the background. And we just hammered that one server, monitored CPU, memory, database. We made sure it was stable, that memory usage was consistent. And then from there, we scaled it up to running the same test across multiple servers. And as you start adding multiple servers, database contention is a big element that we had to watch out for. And we were really just checking the overall performance under high load. And again, website response time. And our ultimate goal, if we had to process 50,000 registrations and we expected to process them in 2 hours, then our test was to run it up to about 150,000 registrations and hopefully about 3 times as fast, so that we knew the system could really handle that peak load. So the good news was that I ran those events for about 3 years, and we had mostly success. We had 10 out of the 12 events went very smoothly. One event did fail. It was a coding error and had nothing to do with the load. And then one event did fail under load, and gets down to my second lesson learned here. The 2 lessons that came out of this load testing was really, as we ran the first load test, even running against one server, we had this occasional very random crash that we were unable to reproduce. And we had the same crash that in manual testing, it happened so intermittently that we couldn't reproduce it until the actual event went live, at which point it happened about 30% of the time. And so that was not a great experience for our users. We were able to get through the registration, but it was painful for our customers. The second time was probably the bigger lesson. And this has to do with load testing the same way that our customers will use it. So one of the things we realized in our load testing, what happened was when we ran a ton of load testing. We ran so much load testing that the DevOps person and I were both convinced this system can run without throttles, right? We've never run an event unthrottled because we were too nervous. We had such high confidence in this that we said, don't even worry about throttles, just let it fly. This was a Peachtree race, 10K, it sells out in about 20 minutes. I think it was about 40,000 registrations in 20 minutes. So this was the highest demand we ever had. And we were both very confident. All of our load testing, it was interesting. All of our load was generated from internal systems. And this was deployed on an internal data center. And not being a network person, it never once occurred to me to actually test traffic coming in from an external point. And so what happened was, as we did this, we ran the test, and everything looked really good from internal traffic. When we actually turned the event on live, all of our customers were coming externally into the data center, and neither the DevOps person or I realized that the management had cheaped out on the T1 line that we had. And so there was a huge swimming event happening that day. A lot of people were logging in to check results from all the swim competitions. And at the same time, our event went live, and we brought down not only our website, but actually the entire corporate network. So the big lesson there that we started doing on following years was we actually rebuilt the load test to test this from a system that would generate traffic from around the world, right, or across the United States in our case, and feed it externally into our system. And we never had a problem after that. That being said, that was a rather painful lesson. All right. Second, so one of the changes we made at that company, as I said, it was the original registration system was a mess of cold fusion and Java. There was a plan to move this over to be a software as a service model registration site. So now we're moving it still into an on-site data center, but we are re-architecting the solution top to bottom. It's all Java services. And at some, when they first built the service, they didn't really worry about load testing because while they built up functionality, they just let a very small number of events go live. So system was not really under strain for a long time until one day the system started crashing under load. And again, they had never really identified any performance metrics or really understood how to size the system because they had not run any load tests. Okay. So in this case, unlike the first example was a system, a website that was designed to work really well for a couple hours and be done. In this case, this is more of a sustained, right? This is our normal registration site. This is always running constantly. And so in this case, our performance metric changed. So instead of looking just at web response time and overall stability, we're now actually measuring the number of orders that our system can process per hour. So from a load test standpoint, we actually started with a baseline case and we ramped up the user base to reach the goal that we had. And then during that time, we were looking still at response time, CPU, memory utilization of the services. We had a couple memory leaks we had to fix along the way. And then the database performance was a big area of concern for us. All right, lessons learned. In this case, really, I think the biggest lesson was really about who needs to be involved in the load testing effort. So this particular one, we did not have a load test team at this time with this company. And so the load test was a partnership with our QA team, architects, DBAs, and DevOps. And really what happened was we would actually run these tests at night and we would all stay online late at night and monitor the actual system. So we'd set up dummy registration events, push a lot of load through it, and we can monitor the system and then stop it. The risk there, of course, is if we start hitting database contention or system contention, we were testing live in production, that actually impacts our customers too. So we had to be very careful about when we ran these tests and very careful to monitor them and stop them if we started seeing problems. The key message and the key lesson I learned out of this, however, is load testing is not a one and done effort. It's very much a continuous effort. And one of the actions that came out of this about 6 months later was they actually formed a load test team and built it up. And that team became the owners of this ongoing load test that we ran. So what I'd say is when you run a load test, you can find your bottlenecks at that point in time, but your architecture and your system is going to continue to evolve, right? We used to release software every 3 weeks. And at any point in there, we might release a change to our underlying services that could break the scalability of the system, right? Or we might need to push the load higher than where it's been because we're starting to push more customers onto the new system. And so both cases, we need to make load testing a continuous effort. Okay, we'll move on to my current company. As I said, our Brink point of sale software today is very monolithic in nature. This is kind of the software I inherited when I joined the company a year ago. Because of the monolithic nature, instead of scaling horizontally like we'd like, we scale vertically. And the big challenge with that is that while it runs on AWS infrastructure, we actually don't know how the system scales. We don't really know what the upper limits are of a stack today. We don't know how many locations we can put. We don't really understand what our bottlenecks are today. And the behavior characteristics of a multi-tenant stack where we have lots of customers compared to, say, a single tenant stack where we have one very, very large customer are radically different. And so we actually have to size for 2 different systems. And today we don't do this. Today, the way we load test our system, or at least the way we load tested our system when I got there, is we have a new release and we find the smallest stack we have, so which stack has the fewest locations, and they're the guinea pigs for the new release. And if that new release is stable, we go find the next biggest stack and the next biggest stack and so on until it breaks. And then we say, okay, we need to start fixing and stabilizing. And putting another release out. And then what happens is we stabilize that stack, and we have to continue working our way up to bigger stacks. So we don't really have confidence to know when we release the software, are we going to be able to handle the load on that stack, right? Or will that stack tip over? And so really this has direct impacts to our customers, right? If our stack is down, if our site crashes, the registers in store may continue to work, but it's a very degraded functionality. They can take orders in store, but online ordering, which has increased dramatically with COVID, goes offline. And so they're actually losing business. And at times the in-store experience can be less than perfect as well. So huge implications for us in terms of customer stability. The other part of it is AWS costs. Because we don't actually understand how our system scales, anytime there's a scalability problem, the first instinct from our DevOps team is, let's go double the size of the stack. Let's go to the next bigger box that we can. And our AWS costs are pretty high because of this right now. Okay, so testing scalability for a monolithic stack is a little bit of a different process. In this case, the good news now is we actually, we have live production data we can look at. So the examples I gave earlier, we didn't really have a lot of production data. Either we had a release target, a targeted number of registrations we needed to complete in a set time, or we were just using a metric like orders per hour that we wanted to process. In this case, we are actually using our production data now to identify in our system, what are the key drivers of load? So as an example, for some customers, we have some customers where they abuse our external APIs. And so we know what that load looks like. We know that they do these hourly or half hourly report pulls of data from our system. We need to make sure that we factor that into a load test. We have special use cases. Change set publishing is a feature that's internal to our system. This is the ability to push out menu and employee changes out to a number of locations overnight. And again, this can put a tremendous amount of load. It was unfortunately not designed real well, so it puts a tremendous amount of load on our system. And for a couple of our biggest stacks, it can actually crash those stacks at times. So that's another area. We want to factor in normal activity for the day, right? Just the normal in-store where people are coming in and buying food, how they're processing those orders, and online ordering. Again, this used to be a low amount of the system load, but this has been increasing a lot this past year due to COVID. So we use the production data, identify our threshold targets for a stack, and then we're looking at any other drivers per load. So for example, the number of store locations and the number of registers that connect all can affect the demand on our system. So we've got to simulate all of these as part of our load testing. What we're trying to build up to is what we call a production activity test, right? We really want to simulate all this load coming in on the system from all directions and be able to actually run this for extended periods of time. So our system, while we do have, it does get busier at lunch and dinner, our goal really is to be able to simulate high sustained load that matches production, but then do it at a much higher level and do it on a continuous basis. So what did we learn? Well, the most important lesson is don't let your customers load test for you. That seems really obvious to me, but it had not been done at our company before. So I thought I'd throw that one in there. Your customers will thank you if the system does not break. The other one I would say is, this lesson number one, right? Get people who understand how to load test the system in. So when I first started at the company, we had a few well-meaning developers who were doing their best to try to load test the system. They had one QA person that was not experienced with load testing who was trying to give them direction. And their load test methodology was very flawed. They looked only at the most abusive use cases. And then what they did was they tried to simply have a system sitting totally idle, and they would drive a spike of activity for 5 seconds and then stop. And that was not really, that did not match a real world experience. It was more abusive than real world, but also without all that load running in the background, it wasn't a very accurate or helpful test. And so the key lesson out of that was to hire people who knew how to load test the system. So one of the first things that I did was I brought in a lead and then hired a team of professionals that really understood how load testing works, right? So we now have a load testing team. We're now making that one of our primary competencies as part of our engineering organization. Second lesson is it's really about maturity, right? The new team comes in here, they understand load testing, but they need to learn the system. They need to understand what drives load and scalability. And then it takes a while to build the test. You don't get a load test team in month 1 and month 2, you've got a great load test. It takes some time to build this up. In our case, we just put a partnership together with the load test team, as well as some of our DevOps and some of our more senior technical people that understood the system. And all that is to help guide the load test team in how to build out an effective test of our system. So we're taking advantage of all that internal knowledge we have about drivers of load. We're in the process of refactoring our stack into more horizontally scaling technologies. And as we do that, we need to continuously test the architecture changes we put in. Again, this seems obvious, but one of the things that was done at this company was we had a huge monolithic release with a ton of architecture changes that went completely untested for a year, and they went, without any load testing for even longer than that. So, if you're going to make extensive architecture changes or improvements to your system, you want to validate that those improvements really help improve, right? It should never make it worse, and they really should help improve the stability and scalability of the system. And you want to make sure that you don't introduce new bottlenecks into your system because of that. So continuously load testing these changes going forward is a big part of our priorities. And then again, with every release, we have both DevOps and our load testing team involved in all the major feature reviews, so that if they see anything at all that they think might warrant load testing, it gets flagged and it comes out as part of our release that load testing is required for this feature before it can be enabled. Again, a lot of these things, I will say, seem very obvious. They had not been done here for years. So it may not have been as obvious as I thought. All right, last example. As I mentioned, we're in the process of transforming our architecture into the AWS Serverless Microservices. And in theory, these are designed to scale and leverage AWS, but they still have to be built properly. And if they aren't built properly, then they're not going to scale as you expect, right? They're not going to scale to the point that AWS infrastructure, right? They should scale up to a point that you can then add more AWS infrastructure and scale further, right? But if you don't engineer these services properly, they won't scale that far. All right. There also could be parts of the system that consume these services, right? Or there could be parts that these services rely on, such as the underlying database, that can be bottlenecks themselves, right? So again, as we introduce these new microservices, we got to make sure not only that they scale, but that everything that they touch or everything that consumes them scales as well. Right, so what we're looking for here are API level tests. We're monitoring throughput, performance, and response times. Our goal is to test, again, first at that microservice layer and validate performance, and then at the higher level layers above it that consume those microservices. And along the way, we want to be monitoring CPU, memory usage. Should remain, nice sawtooth pattern where it consumes memory, does a memory cleanup, consumes memory cleanup, and that should continue forever unless you have memory leaks. And then the last one is we're looking at the underlying database, right? As you add a number of services scaling over time, you can add contention to your database. And so that's what we're looking as well. And then the last question in there is, at a certain point, if we increase the AWS infrastructure, so this goes directly to how we size our systems now, we want to know for that initial size infrastructure, how far can we scale? And if we add more infrastructure, do we get, do we increase scalability and performance by that same amount? And so that's what we're looking at with our tests. So when we get into lessons learned now, this is probably the most extensive load testing that I've been a part of. We were just starting to get to this at Active Network when I had left them. But what we're really doing now is we're building up a continuous load testing proficiency here, right? We want to be amazing at load testing. And this is really an ongoing process for us. This is not, again, not one and done. This is an ongoing process where we are always designing the tests, executing them. And we're not only analyzing the results, as far as looking for bottlenecks and stability issues, but we're also constantly tuning the tests, right? So we are constantly looking at the test to see if it's effectively measuring what we thought it was measuring, if we need to make adjustments, if we're missing something. if our customers are changing their usage pattern. So this is an ongoing cycle of running our tests across a quarter or across a release, and then turning around and improving the test for the next cycle. Probably the biggest lesson coming out of this. And again, I say that, it seems kind of obvious, but again, when I came here, we had a couple of people that were less familiar with load testing that were really simply looking to spike a couple of the key resource utilization use cases and stop there. And so this is a fundamental change for how we do load testing at the company. These are just some of the things that we're looking and different types of tests that we're running, right? Again, our goal is to be pretty extensive. We're not yet running all these today. These are what we're building up to right now. For reference, our load testing team was hired over the summer. And so we have great ambitions to get most of these in place by the end of the year. One of the key factors of our system is connection testing. And so it's, we can have, if our system goes down, if there's an internet spike, we can have a number of registers that need to reconnect to our system in a short period of time. And this right now is one of our known pain points, right? Sometimes our server crashes when this happens. And so this is what we're building into our load tests because we've never done this before. And this is something that happens under, we all know AWS has outages, right? The network, the internet is not 100% foolproof. It has outages and we need systems to be able to reconnect. Production activity test, I alluded to this one earlier, but this again is building up a load test that's representative of all the primary business activities that happen on your system on a daily basis. And the real output here is, can your system handle that load on a continuous basis? And then if you scale that load up, how much load, how much activity can your system handle before you start running into bottlenecks? Peak tests would be more about just sending it a short-term surge. So let's say that we had, just on top of all of our normal activities, we had a whole lot of online orders injected into our system, or a high level of report requests in the middle of all this activity. We want to make sure, again, our system is stable and can handle that. Endurance tests would be more of, we're going to run this production activity for an extended period of time, might be, for a week or so, just on a system. And again, there what we're looking for is putting it under high load that's representative of our production system. If we put it under very high load and we, to the point that we should be straining the system, does the system stay stable if we run it for a week or 2 weeks? In our case, we do have some asynchronous processes that we have to factor into the test. So this comes into knowing what your use cases are and design the load test intelligently. And then failover, right? Now we're starting to get into the more advanced system parts of the test, right? Once you've got basic load established, you also want to know what happens if part of my system goes down, right? The load doesn't stop. How does the rest of the system handle that load? Or from a recovery standpoint, if we take something down and re-enable it, right? A service restart in the back end, does the system can it absorb that load quickly? Does it keep performing? Or does the entire system come down? All right, so what we found is load testing, very much a continuous process, and it's going to be a continuous effort to mature this over time, right? We have a load dedicated team working for us now. We have key stakeholders that they work with who are involved in designing and executing and reviewing the tests and constantly tuning them. We are looking at all different levels. So while we do have system-wide testing that we do, we also test individual microservices. We also load test any major architectural change or feature that comes out to make sure that it didn't destabilize the system. And going forward, our goal is to actually, as our agile maturity process continues, at some point we may actually embed load test representatives onto each of one of our dev teams as well. So they might be part of that Scrum team. And again, this just improves communication so that we have visibility on any changes that may impact system load or performance, that they get filtered back into the load test team so that we have somebody else that can write tests to verify system performance. Okay, so the big question that really comes up, right? Because it does cost money to staff a team. It does cost money to run load tests, right? So the big question that comes up is this really worth it? Do I need to do this? And I'm gonna say it depends on your scale and your growth path. At Partech, we have a goal to scale about probably about 20 times greater than where we are today. And In order to do that, we're going to have to make significant investments in our architecture, and we're going to have to prove that we can handle that much load. And we're moving to from multiple vertical stacks to having one cloud-based offering that scales horizontally. We've got to make sure that we scale horizontally along the way as we make these changes. So for us, what this really comes down to is, do we want to be proactive or reactive? Do I want to know where my system bottlenecks are before my customers do, and know at what point I'm going to have to invest and address the next round of stability changes? Or do I just want to wait until my customers tell me and then react? When the challenge with this is, if you struggle under load, it will become the most urgent problem you have, right? Because your customers are going to be very angry for you. If they load test for you, then they will be asking you and your team, for daily status reports and expecting you to work all night long to stabilize the system. And I've been there before, and it is extremely unpleasant. I don't recommend it. But that's what it really comes down to, right? If you do this out front, your customers will thank you. And that's the important message here, right? You will have met that contract, that commitment you have to your customers to provide them with a stable set of software. Okay. So benefits of load testing really come out to be proactive, own the performance of your system and the response time and the scalability, and know where your limits are and know when you're going to hit those limits so that you can proactively plan to smash through them. If you don't know, it just becomes an emergency and you become very reactive instead. Knowing before your customers how high the system scales is important. Know where the bottlenecks are, when they need to be tackled, and most importantly, or not most importantly, but as importantly, know how to size your system properly, right? There's, again, very efficient use of AWS. You don't want to pay for more AWS infrastructure than you need. And last one down here is know whether throwing more hardware at the problem will even help you, right? If your system does buckle under load, if you've tested this before, adding more hardware and seen that improves scalability, you'll know that this is an option. Hey, I can go throw more hardware at the problem, and I've solved the immediate customer urgency need, and now we can focus on fixing the bottlenecks in the background. If you've not done this test before, you may add more hardware and it may not help. All right, and with that, any questions?
Sure. Thanks, Brian. Maybe you covered this and I missed it, or if so, apologies for asking. Talked a lot about overall performance testing and scale testing and how things scale up. Have you looked at how things, was it part of the scope to look at how things scale down when load decreases so that cloud costs don't stay higher like after a sustained load?
Yeah, that's a really good question. And the answer is we have not done that yet, only because at the moment we're still more focused on knowing the scalability limits of our system. And because we deployed as monolithic vertical stacks today, it gets very hard for us to change that system size on the fly. But your question is absolutely a great point, because as we move forward into that AWS Serverless Microservices and that new architecture path, one of the key things that we really do look at is we want to make sure that, as your load scales up, it's designed to take advantage of AWS and spin up, in our case, more Lambda processes, process that load, and then close that demand back up as you don't need it. And so that is definitely something, as we load test our microservices, one of the things that we actually do is we will run the test and then we'll report on some AWS costs for the test itself.
So Brian, you talked about this, you kind of did this transition from like, wow, we have like, kind of developers who aren't really experienced to like, let's get a dedicated resource in here that really understands this. Like, let's say a company wanted to bring in a dedicated resource. Like, how do you, like, what do you have them work on first? Or like, what's kind of like the first step for them?
Great question. So when we brought in somebody into our organization, because we already had people working on the tests, and we were in the process of getting a release out the door, we had them join that effort. And by joining that effort, it gave them a chance to start understanding the use cases of our system, just because they came off the street, they didn't have that knowledge. And then it also helped to understand, given that usage, okay, what are these load testing and what are they, more importantly, what are they not testing? So it was really just getting their feet on the ground and getting them to understand our system. And that hands-on knowledge for a couple months was really instrumental then, because that lead person could turn around and say, okay, now that I've got a better understanding of the system, they went off and formulated a test plan, right? So we actually have a documented load test plan that talks about all the different types of tests we need to build. And then, within each of those tests now, they start consulting architects and DevOps and some of the leads about making sure we get the right use cases and traffic. But having their first step be just get some hands-on knowledge of the system was probably the most important step.
Sorry, just a follow up. What's like a realistic timeline if you bring in, a dedicated resource like that to like getting to a point where these load tests are useful?
Good question. I think that's going to depend a little bit on the complexity of your system. As an example, when I did the one-off website testing hands-on, it was such a simple use case. It was it was really easy to measure. In our current system, where we've got a lot of different drivers of load, it's going to take a while to staff up that whole team and get them focused on the different areas of our system. So we built the team up this summer. They started in earnest in July, building up a set of use cases and building towards this production activity test. And it's going to be about the end of the year where we've got the first round of that production activity test ready to start testing with. So about 6 months. And that's with the team being on site for a couple months ahead of time, learning the system and learning the use cases.
Brian, question. When you guys are building out these, the production activity tests, are they coding those manually, or are you guys using a tool to kind of set up and drive those tests?
Oh, good question. So the tests that we're building up today are all API based. Some of the use cases are SOAP-based, some are REST-based APIs. And the tools that we're using are JMeter for the initial build out, and then BlazeMeter for running them under higher levels of load.
Okay.
One of our challenges is actually is that parts of our system today are only accessible via a proprietary binary protocol. And so we're in the process of refactoring that into a REST-based API, because right now we can't drive some of the testing activity we need to drive. And so prioritizing that has been an important step for us too.
So when you're coming up with the kind of that traffic profile for the production site, like how are you modeling that? Are you looking at the actual data and then sort of turning that into JMeter scripts, or what's that process?
That's exactly it. Actually, we monitored it as an example. We have a lot of API requests into our system. And so the first step was going out to some of our bigger stacks and just looking at the production data we have. We do have a lot of monitoring instrumented on our systems. So we were able to go in and analyze what that traffic is, and then do a deeper dive with a couple of the architect team members to really dive into what those requests were. And because it's not just hit it with 100 API requests, we want to get the right mix of what those 100 API requests are. So some of them are requesting orders or pricing orders or submitting orders. Some of those are different data pull requests. And so we had to dive in and get the right balance. But it starts with monitoring your system and just understanding that load, and then working with some of the experts in the system to help refine that and build up an accurate model.
What type of database are you using?
Right now, our system heavily uses Microsoft SQL Server. We have parts of it that are moving over to Aurora Postgres for some of our extended reporting capabilities. But for our operational needs, it's all Microsoft SQL Server today.
And how do you scale the database resources?
At the moment, again, it's been just by throwing more hardware at the problem. Because we've not done this level of load testing in the past, as we start to see database bottlenecks, today it's simply throw load at it. I expect as we start refining these load tests, what we're going to actually do is bring some DBAs on staff, which have never been part of the team before, and actually start having them as part of this load test, understand and monitor what's going on in the database, because we all suspect we have lots of bottlenecks in our database today. That we just don't know enough to catch. And so we're going to be looking at that next.
Brian, thank you again. Great.
Thank you.
Good job, Ryan.
Yeah, nice
you.
job.